AI has just fundamentally changed everything about exploring Mars.
It's this huge shift.
Yeah, we're talking about going from, well, basically fancy remote-controlled cars
Mm-hmm.
to explorers that are genuinely autonomous, thinking for themselves.
That's the goal.
So our mission really is to track how this Martian intelligence evolved, from the very beginnings, the simple stuff, right up to the kind of sophisticated AI pioneers we see today.
And understand how they're really reshaping our whole quest, to figure out the universe's secrets.
Exactly. And we're drawing all this from a really interesting document called How NASA's AI Rovers Are Exploring Mars Without Us.
Right. And the core reason why this AI became so necessary, it just boils down to physics, really, the sheer distance.
The distance problem.
Yeah, you've got radio signals traveling between Earth and Mars, and depending on where the planets are, aligned, that signal takes anywhere from 4 minutes to 24 minutes.
One way.
One way, exactly.
So real-time control, just forget it. It's impossible.
Completely off the table.
Imagine a rover sees a cliff, or maybe, I don't know, some amazing sparkly rock.
Uh-huh.
It can't just stop and, phone home for instructions. It needs to act now.
It absolutely has to. There's no waiting around. And that delay, that unavoidable lag, well, that's what really pushed NASA engineers.
Right.
It forced them to develop these, well, pretty sophisticated AI systems. Systems that let the rover make decisions that are, kind of human-like, but in real time.
So it can react instantly without waiting for us back on Earth to tell it every little thing to do.
Precisely. It responds to its environment as it happens.
Okay, so let's rewind. Where did this all start? What was that, the very first step onto Mars with wheels?
That would have to be Sojourner. Way back in 1997.
Okay.
Our first wheeled explorer on Mars. And, it was amazing for its time, proving the concept worked.
But pretty basic tech by today's standards, I guess.
Oh, absolutely. It was about the size of a microwave oven.
Huh, really?
Yeah. And honestly, it was mostly just a remote control vehicle, very dependent on constant, detailed instructions from Earth for almost, every move it made.
So proof of concept, but not much thinking for itself.
Not really, no. Very limited in that sense.
So where did things go from there? I know Spirit and Opportunity came next around 2003. Did they start to get a bit smarter?
They did, yeah. Spirit and Opportunity, they definitely introduced some, let's call them basic autonomous capabilities.
Like what, for instance?
Well, they could spot an obstacle right in front of them and, stop or maybe go around it, avoid immediate hazards. And they could run pre-programmed sequences of actions.
Okay, so a little bit of independence.
A little bit. But they still relied very heavily on mission control, sending up super detailed plans every single day. Still very much guided, step by step from Earth.
Right, gotcha. Okay, now this is where things seem to really take off, at least from my perspective watching these missions. Curiosity, 2012. It had something called AutoNav. How big a deal was that?
Oh, AutoNav was a huge leap. Monumental, really.
Okay.
With AutoNav, Curiosity could actually look at the terrain around it, figure out safe paths, and drive around rocks and obstacles without needing a human driver back on Earth guiding every wheel turn.
Wow. So it could actually, plot its own course.
To a large extent, yes. It wasn't just about covering more ground faster, though it did that too. It really changed the rover from just being, a camera on wheels into more like a semi-independent field geologist on site. It could follow leads, make choices about where to go next. That used to take days of back and forth communication.
So it wasn't just driving faster then? That wasn't the main point?
Not the only point, no. It could drive maybe up to 40 meters a day on its own, which is way, way more than Spirit or Opportunity could manage.
Right.
But the really clever bit, the crucial part, was that its AI could look at rocks and decide, that one looks interesting, before sending all the data back home.
Intelligent filtering.
Exactly.
Right.
Filtering on Mars. So
Yeah.
every bit of data transmitted across those millions of miles, it's already been kind of pre-screened for scientific value. That massively boosts the science return you get for your communication budget. It changes the whole game.
That's clever. Okay, so that leads us up to Perseverance. Landed February 2021 in Jezero Crater. This is the current state-of-the-art, right? The pinnacle of Martian AI, starting with its navigation.
It really is, yeah. Perseverance's AutoNav is even more enhanced. It uses stereoscopic images, basically two cameras acting like eyes for depth perception, to build these incredibly detailed 3D maps of the terrain ahead. They can see maybe 100 meters out.
100 meters.
Yeah. And the AI can tell the difference between, say, dangerous loose sand and hard bedrock, or identify sharp rocks to avoid. It actually evaluates multiple potential routes at the same time
Wow.
and picks the best one based on, safety, speed, and maybe which path goes past scientifically interesting spots.
So it's not just driving, it's making science decisions while it drives. But beyond getting around, I gather its AI is key for the actual science too, like deciding which rocks are worth sampling.
Oh, absolutely crucial,
Ah,
especially for the Mars sample return mission goal. Perseverance uses machine learning algorithms.
okay.
These have been trained back here on Earth on literally thousands of images of different rocks and geological formations.
So it knows what to look for.
Kinda, yeah. The AI analyzes things like rock texture, color, even hints of composition, to flag samples that are most likely to hold clues about ancient Martian life, if it ever existed.
So it's prioritizing the best possible samples to eventually bring back, making sure every gram counts.
Exactly right. You want the highest possible scientific value packed into those samples.
And it seems like it's also really good at just coping with Mars. That real-time adaptation sounds impressive.
It is pretty remarkable. The
Mm.
AI systems are constantly monitoring everything, the weather, how much power it has, the status of its own instruments, and it can change its plans on the fly. So if a big dust storm kicks up, it might decide, okay, let's postpone that energy-heavy drilling activity. Or it might adjust its solar panels to catch more sun, or even run some basic self-checks if a sensor seems a bit off.
That makes sense. Okay, and then the helicopter. Ingenuity. This just blew my mind. A flying machine on another planet.
I know. It's just an incredible achievement, both engineering and AI working together. Ingenuity first flew April 2021. Autonomous powered flight on Mars.
And the challenge is that atmosphere. It's so thin.
Ridiculously thin, like
Right.
1% of Earth's atmosphere density. Normal flight, like we know it. Impossible.
So how did the AI manage?
Well, the AI basically had to learn to fly in conditions that we couldn't perfectly simulate here on Earth. It uses its onboard sensors, accelerometers, gyroscopes constantly, hundreds of times every second, just making tiny adjustments to stay stable and fly.
Wow. And it wasn't just a can we do this tech
Yeah.
demo, right?
Yeah.
It actually became useful.
Hugely useful. Very quickly, Ingenuity became this AI-powered scout for Perseverance.
A bird's eye view.
Exactly. From up high, it can survey huge areas really quickly, spot interesting geology, or map out safe driving routes that would take Perseverance days, maybe weeks, to find just by driving around.
So they work together, the rover and the helicopter.
It's this amazing synergy. Integrated aerial and ground-based AI, a totally new, powerful way to explore.
So all this machine learning, how does it hold up in such an extreme place? Mars is, well, it's brutal.
It is incredibly harsh. You've got insane temperature swings like minus 80 Celsius up to maybe 20 Celsius near the equator.
Yeah.
Cosmic radiation bombarding everything.
Yeah.
Abrasive dust storms.
Yeah.
NASA's AI systems have to be built tough, really robust,
Yeah.
but also adaptable.
Adaptable how?
Well, the algorithms can actually change their own behavior based on what they learn. So if it tries to drive through a certain type of sandy terrain and gets stuck,
Oh.
it learns from that. Next time it sees similar terrain, it might try a different approach or just avoid it altogether. It adapts based on experience.
And I heard something about predictive maintenance, using AI to guess when things might break. That sounds vital when you can't just send out a mechanic.
Oh, it's a game changer for mission length, absolutely. The newer rovers use AI to look for subtle patterns, maybe tiny changes in how much power a wheel motor is drawing, or slight degradation in a sensor's readings over time.
Okay.
By spotting these patterns early, the AI can help mission controllers back here predict potential failures before they happen.
So they can work around the issue, maybe use that wheel less, extend the mission life?
Exactly. It could add years to a mission, which, given how much these things cost, is incredibly valuable.
This level of autonomy is just mind-boggling, but it must come with challenges, right? Limitations. You said it. You can't afford mistakes up there.
You're spot on. That's the biggest challenge. Reliability. Unlike AI development here on Earth, where you can test, fail, tweak, repeat.
Yeah, iterative design.
Right. For space missions, there's basically zero room for error. The AI has to be tested, validated, verified to an unbelievable degree before launch. Because once it's on Mars, that's it. No software patches, no hardware fixes.
That's intense pressure, and power must always be a constraint, too.
Always. These rovers run on limited power, either solar or, for Curiosity and Perseverance, radioisotope thermoelectric generators, RTGs.
Like a little nuclear battery.
Essentially, yeah.
Yeah.
But the power output is finite, so every calculation the AI makes, every move, has to be incredibly efficient. You're constantly balancing how smart you want the rover to be versus how much power that intelligence consumes.
A constant trade-off.
And, Giving the rover more freedom, more autonomy, while amazing, also introduces new kinds of risks. What if the AI encounters something truly bizarre, something its designers never anticipated?
Right. How do you plan for the unknown unknown?
You build in multiple layers of safety, fail-safes, the ability for the rover to recognize it's confused or in trouble, and maybe revert back to a simpler, safer, more basic operating mode until humans can assess the situation. Risk management is huge.
Okay, so looking forward then, what's next? Where does NASA see this AI technology going? Even more autonomy.
Definitely. NASA's already working on the next generation. We're hearing concepts like collaborative intelligence.
What's that?
Imagine multiple rovers, maybe some flying drones too, all working together as a team, sharing data, coordinating their exploration, covering more ground more effectively.
Like a little robot swarm on Mars?
Kinda, yeah. And also things like advanced science autonomy, getting the AI smart enough to not just follow plans, but maybe even design and conduct simple experiments on its own based on what it finds.
Wow, the AI is the scientist.
To a degree, yes. And developing better ways for humans and AI to work together. Maybe AI guiding robotic arms for really delicate sample handling or assembly tasks in the future.
And I assume this isn't just about Mars anymore. These lessons learned, this tech, it's going further out.
Oh, absolutely. Mars has been the proving ground, but the AI developed there is basically the template for exploring even more challenging places.
Like where?
Think about missions to Jupiter's moon Europa or Saturn's moon Titan. The communication delays there are much, much longer than Mars. Hours, not minutes.
So autonomy isn't just helpful, it's essential.
It becomes completely non-negotiable. And the environments are even more extreme, intense radiation near Jupiter, super cold liquid methane seas on Titan. Future explorers there will need even more sophisticated AI to survive and do science.
So connecting all this back, what's the big scientific payoff? How is AI actually changing the science we get from Mars?
Well, the biggest impact is probably the sheer acceleration of discovery.
Faster science.
Much faster. Because the rovers can make observations, analyze data, and decide what to do next on Mars, operating on the timescale of a Martian day.
Instead of waiting days for instructions.
Right. Instead of that slow back and forth dictated by the light travel time, this speed means we're finding things, making connections that might have been totally missed or would have taken years longer using the old remote control methods.
And maybe enabling totally new kinds of science, too.
For sure. With smart rovers and advanced instruments, you can do things that were just impossible before. You can track changes over time much more easily, watch frost form and disappear, monitor weather patterns, conduct really complex studies looking for correlations between different data sets like chemistry and imagery, right there on the spot.
It really feels like a different era of exploration.
It absolutely is.
So, wrapping up this deep dive, it's just undeniable, isn't it? AI hasn't just helped Mars exploration, it's fundamentally transformed it. We've gone way beyond remote control into, well, genuine autonomy.
A true paradigm shift.
And these explorers, they're not just, picking up rocks. They feel like digital pioneers out there. They're writing new chapters for us in space, and they're actively, literally paving the way for humans to eventually go to Mars.
Preparing the ground, yeah.
So here's something to think about. Mars, the red planet, it's millions of miles away, feels impossibly distant. But through the eyes and the minds of these AI rovers, Mars has somehow never felt closer. Does that make sense?
It does, yeah. We have a presence there, an intelligent presence.
Exactly. These machines are uncovering secrets about the universe at a speed nobody could have dreamed of just a generation ago. And it really hints at this future where autonomous intelligence isn't just like a helpful tool.
Yeah.
It might become our main way of reaching out and understanding all those other distant, unknown worlds out there in the cosmos.
A fascinating thought. The future is autonomous, perhaps.
It really might be.